All right, so I'm going to go over the first way to determine percent composition, all right? And this is if I give you grams. So in this problem, in this example problem, I give you that you have 8.2 grams of magnesium, all right, and 5.4 grams of oxygen. So if I were to give you the number of grams, this actually really isn't too bad because here's what you can do. So here's magnesium, and you know that it has a mass of 8.2 grams, okay? And then for oxygen, you know that it has a mass of 5.4 grams. Okay, so if I say what percent of the compound is magnesium, what percent of the compound is oxygen, all you have to do is the following. You need to determine how the mass of the entire compound first of all. Okay, and so we'll do that right now by adding them together, and what you get is that it's just 13.6. So the entire compound has a mass of 13.6 grams. And now what you need to do is take each element and decide this mass, so 8.2 grams, what percent of the entire compound is that? Okay, and as soon as we're talking about percents and what percent of something is it, we're going to be dividing. So for magnesium, all we have to do is the following. We're going to take magnesium, and we're going to say, okay, it has a mass of 8.2 grams, okay, out of the entire compound, which has a mass of 13.6, since we added those together. Okay, so we're going to divide. We're going to take 8.2, divide that by 13.6, and that's going to give us a decimal. So if you take your calculator and take 8.2 divided by 13.6, what you should get, if I do it correctly, is 0.603. So 0.603. Now that's a decimal, and I want to convert to a percent. So I'm going to move my decimal place over 2 places. So 1, 2. So my percent here is just going to be 60.3%. What that tells me is that 60.3% of my entire compound, of this 13.6 grams of my compound, is magnesium. Okay, not too shabby. Well, here are your 2 options for finding oxygen, and I'm going to do it both ways to check my work. Okay, we know oxygen has a mass of 5.4 grams. So for oxygen, I'm going to do this math again. I'm going to say, okay, 5.4 grams of my entire compound is oxygen out of the total 13.6. So I'm going to divide again. So 5.4 divided by 13.6, and I get 3.397. Okay. Remember, I have to convert this into a percent, so I'm going to move my decimal place over 2 points. Okay, 2 places, and I get 39.7%. Okay, that's the first way to do it. So I just take each of these individual elements, I divide their mass by the total mass of the compound. Okay, so 39.7% of the compound's oxygen, 60.3% is magnesium. What you should notice, however, if I find the percent composition of magnesium, which is 60.3, it would only make sense that the rest of the 100% that makes up the entire compound would be oxygen. So the other way that I can do this, instead of having to calculate oxygen this way, I could just take 100 and subtract 60.3 from it. And what I get is 39.7. Okay? So if you want to do it this way, that's fine. I kind of like doing it this way so then I can go and check my work. But notice they're the exact same thing. It's 39.7%. This is the first way to determine the percent composition, and the only way I can use this is if I'm given grams. All right? So you're going to watch the other video in which I'm not given grams, and there's a different way that I can do this.